Hi, today I'm going to show you how to sketching absolute value functions. Okay, so as we know, absolute value function is like a piecewise functions. So with the first question I have here, so we first change it into piecewise functions. So there will be equals two pieces with one absolute values. First piece is just equal to x if x is positive numbers or zeros. Or if x is a negative numbers, then the absolute value has to be a positive. So we put extra negative on the negative x values to get a positive numbers. So this is the piecewise functions. So the piecewise function we can sketch in this way. I'll show you. So it's x-axis and y-axis. So the first piece is y equal to x. So it's going to be like this. Y equal to x. But we only need for x bigger than equal to 0. So going to become this only and without the other parts. So I'm going to remove that. Okay, and then the second half is y equal to negative x. So y equal to negative x is going to be like this. But as you realize, we only do that for x is less than 0. So which means we only can have these parts. And I'm going to remove the other half. And this half we have y equals to negative x. So together we make the whole curve is y equals absolute value of x. So this is the sketching of absolute value of x. But as you can see, we changed the absolute value functions into a piecewise functions, and we did the two pieces. But we have a different way to approach sketchings, as every time we need to change to piecewise, there's quite a lot of work. So we can have some other shortcuts. So first cut is we using the basic curve, which is y equals absolute value, which I draw here, the V shape, to do some translation. So let's see some questions like translation questions. So if we know y equals to absolute value x, and how do we translate into y equal to 2 absolute value x? So you can see is every single y value is multiplied by 2. So end up with a curve is going to be more steeper. So I show you. So we don't have to do the piecewise, we just do the translation. By using the original one, make more steeper, because every single y value is times by 2. So that number become 1 and 2, and that number become negative 1 and 2. So that's it for the first one. Second one, we're using the original one to translation because we have y equals absolute value x. Now we have y equals negative absolute value x. So which means the curve is just flipping on the x-axis entirely. So that is y equals negative absolute value x. And next one, we have negative and we have half. So we have two translations. One translation is every single y is times by half. And another translation is every single y times a negative, so negative half. So we flipping down on the x-axis, and we also make a wider. Like this. So the point here we can have is 1 and a negative half. And here we can have negative 1, negative half. So that's it, we're done. Next one. We have absolute value of x minus 2 absolute value x. So what we do is we do shifting to the right by 2 units. So then it would become like this. So it's 1 and 2. So then we do normal translation. And that number becomes 0 and 2. That's it. Okay, and next one, we can have absolute value of x, then minus by 2. So how does that go? Just move whole curve entirely by 2 units down into negative 2. So then we go to here. So that number become 2 zeros, and that number become negative 2 0. The next one, this double translation. First one is shifting to the left by 1, and then moving down by 3 units this time. So let's have a look. So I move to here, y and x. So left by 1, so negative 1, down by 3. Okay, negative 3. So that's where you move up to. And we have to be aware of your x-intercept, y-intercept. This time the y-intercept become negative 2. So that's negative 2. That's y-intercept. X-intercept will become, let's see, if equal to negative 4, negative 5 and positive 2. So positive 2 here, negative 5. 3, 4, 5. Wait, negative 4 should be here. Okay. Now let's do it. So we have this, and we have this. And that number is negative 1 and a negative 3. Okay, next one, move on. So this time we have y equal to absolute value of 2x plus 4, 2x. So if just x plus 4, we're shifting to the left by 4 units. But this time is 2x plus 4. So 2x shifting to the left by 4. So 1x will be shifting to the left by 2. So it's in the end become by 2. So 1x shifted by 2. So again, negative 2. And the y-intercept will give you 4. Because it's 2x. So you will have steep up because 2x. So it become like this. The next question, y equals to 1 minus absolute value of 2x minus 2. So with the absolute value part, 2x minus 2, we can see 2x shifting to the right by 2 units, means x shifting to the right by 1 unit. Okay, so that's first thing. And then because of the 2, we know the y value is going to be times by 2. So we have to make sure the curve is a little bit steeper. And also negative means you're flipping on the x-axis. And finally, we plus 1 unit up. So let's see how the curve goes. So lots of things going on here. So we get the point shifting to the right by 1 unit. So this is 1, and also shifting 1 unit up. So this is also 1. So we get that point 1, 1. And again, your y-intercepts for the 2x minus 2 would be negative 2. But since we're shifting 1 unit up, so become negative 1. So that's the y-intercepts. And x-intercepts is going to be 3 on 2. So if this is 2, this will be 3 on 2, and would be a half, positive half. Right. So that's all we need to have. Now we can go for it. So become like this. It's a bit steeper, and this. That's it. All good. So the next one, we're going to do the different method. So the different method, you can see the question are called shortcut. So what's the shortcut is? You can see all the question here. There's a 4 question I wrote here. every single question is with the entire function is absolute valued. And inside we can have lots of different functions. Basically any function inside, that's fine. But with all absolute valued outside, then what does it mean? It means whatever the function value need to be positive. Need to be positive of the original values. So if the value is -2, so your final value will become +2. But if the value was originally 2, the function value is still going to be 2. That's the meaning of absolute value. So it's very easy to do those type of questions now. So we just need to sketch in what's inside of the absolute value, that function it is. And then because we absolute value of the functions, so we just make sure all the y value is going to be keep the same if it's positive, or it's going to be a positive value of the negative values if it's negative. So I show you the first questions. Okay, let's see. So first questions, inside was the absolute quadratics. So it's a parabolas. So with the x-intercepts is 3. And the y-intercepts 3, and then I think the other one is -1. Yeah, y-intercepts is going to be -3. -3. And then your vertex is going to be 1 and a -4. So that's your vertex. So your curve would be like this. That's your curve. But as I said before, because we fully absolute valued, so I'm going to use a different color of my final curve. So if the function value is positive, we're going to keep whatever it is, which basically is still this and that. So it's the same. And all the value is negative, we're going to change same value but positive of that. So for example, y-intercept was -3, so I'm going to change to +3 now. 1, 2, 3, +3 now. So your vertex is 1, -4. I'm going to change to 1, +4 here. Okay, so in the end, your curve is going to be mirror image on the x-axis for these negative parts. So the red curve would be your final answer. So we can follow exactly the same idea for the question 2. We're sketching the middle one first, and then we're flipping. So the middle one would become, the inside is the cubic curve. So with x-intercept 0, 1, -1. And when x equals 2, the y value is going to be positive, so somewhere here. So that's how we go. So it's like this. And then we absolute value of that. What does that mean? It means we just make positive, still positive, like this. Still positive. And the negative also become positive, but mirror image become this. That's it. So that's very easy. But the key is you have to know how to sketching the basic curve, inside the curve first. And then we can sketch in the rest of it by flipping on the x-axis. Okay, so let's do the first one. Sketching inside. See, inside this is hyperbolas. So let's do hyperbola. Is shifting to the right by 1 unit hyperbola. So we have asymptotes at x equals to 1 here. And then we just do normal sketchings. -1 here. So that's the curve. Oops, don't touch the x-axis. And then that's the curve. And then we do absolute value of that. So very easy. Positive still keep the same. So the whole entire curve piece here is positive. And then all the negative, we're going to mirror image to positive. So y-intercept become positive 1. So mirror image become like this. Okay, let's see the last questions. So last question is the log functions. So we're just sketching the log inside, and then we're flipping the negative to the positive. So log curve, we know all the x value can only be positive. So, and the y value is like this is log curve. This is the log curve with x-intercept 1. Okay, let's do the absolute value of that, which is basically just flipping and keep the positive. So I keep the positive and flipping. That's it. So this is the shortcut. Shortcut only works for if you absolute value of entire functions. But what if question is not absolute value entire function? It's absolute value of part of the function. So this is the last step I'm going to show you here. I call it piecewise. So this is the one there's no shortcut. And this is the one has absolute value. And also this one cannot do translation. So this is the one we can only go piecewise. So using the definition of absolute values, we change the whole function into 2 pieces, and then we sketching each piece. Okay, let's have a look at the first questions here. So firstly, we're sketching the curve into 2 pieces. First piece is x squared minus 2x minus 3 with the x is bigger than or equal to 0. So second one become plus 2x because when x is negative, absolute value of x gonna be negative x. So these are the 2 pieces. So the sketching will be like this. So with the first parabola, y-intercept negative 3 and x-intercept is 3 and the negative 1. So it's going to be like this. Vertex is 1 and 4. Okay, so it's going to be like this. I do dotted first. Oops. But with the condition, this only for x bigger than equals to 0. So what does that mean? Means we are only sketching bigger than equal to 0 part, which is that. Only that bit. I'm going to remove the other dotted. You can't have this. Yeah. And the same idea for the second piece is x squared plus 2x minus 3. So it's the same y-intercept, but the vertex is going to be negative 1 and 4, and then your intercept is going to be 1 and a negative 3 here, negative 3. So I draw dotted first. So this is a problem I have, but what condition is x less than 0? So I only can have x less than 0, which is these parts of the curve. But I can't have the other half because that's x bigger than 0, so I'm going to remove it. Yeah, so that's your final curve. Looks like a W. Piecewise function is always like this. Okay, now let's see the next questions. Is y equals 2x minus absolute value x. So I'm going to we're going to change to piecewise. First is when x positive become 2x minus x. This is if x is bigger than or equal to 0. Then the second will be 2x plus x. This is if x is less than 0. So I'm going to do a little bit simplifying. So first one become just x if x bigger than or equal to 0. Second one is 3x if x is less than 0. So sketching this is a bit easier. So it's like this. To do here. So first one is y equal to x. It's going to be like this. And I only draw this part because the other parts is negative x, which is not in that case. So when x is negative, is 3x. 3x is more steeper, so it's going to be like this. And I only draw this part because it's when x negative. So that's the answer. Next question. So this question has two absolute values. So it's going to be more complicated. So I'm still going to change to piecewise functions. And the two absolute values will give you 3 pieces. What are the 3 pieces? So I'm going to find in the critical value for each absolute values, which makes each absolute value equal to 0. So first absolute value is x plus 1. So the critical value will be negative 1. I'm going to put on the number line negative 1. And for the second one, it's going to be 2, which makes 4 minus 2x equal to 0. So I'm divide the whole number into 3 sections. I'm going to put them in different colors. So first one, I'm going to make it red colors. And the second one making blue. And the last one making green. So let's do each section, each cases, and makes each one different pieces. First piece, y equals to, when x bigger than equal to 2, I'm taking one number in that section, which is say x equal to 3. So the first absolute value will give me positive numbers. So I'm going to open it, make just equal to x plus 1. And the second one, when x equal to 3, will give you 4 minus 6 in negative numbers. So I'm going to take extra negative to make positive for second absolute values. So that's how you open your absolute value. So in the end, it becomes x plus 1 plus 4 minus 2x. So y is equals to negative x plus 5. So this is when x bigger than equal to 2, first piece. Second piece, I'm going to do the blue. So y equals to when x in between negative 1 and 2. Let's say when x equal to 0. So the first absolute value is still positive. And the second absolute value now become positive. So I'm going to keep as positive like this. So become y equals to x plus 1 minus 4 plus 2x. So y is equals to 3x minus 3. This is if x is in between 2 and the negative 1. But of course, you can also keep the 2 negative, will be the same, no problems. And the last one is green cases. So when the x is less than negative 1, say for example, x equals negative 2. So the first absolute value this time become negative. So I'm going to put a negative of that. Second absolute value is going to be positive. So I just leave as that. So in the end, I have negative x minus 1 minus 4 plus 2x. So which gives you y equals to x minus 5. This is if x is less than or can be equal to negative 1. So these are the 3 cases. So I'm going to draw on the number plan to see how the curve look like. So I'm going to put it in here. So the first piece is y equals negative x plus 5. So since it's red case, I'm going to draw in red. Negative x plus 5, the y-intercept is going to be 5, x-intercept is going to be negative 5. Let's say 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, negative 5. So here to here. But I'm not going to draw a whole line. It's because we have x bigger than 2. So this is 2. And when x equals 2, y is equal to 3 here. So this is the one. Yeah. 5 is the x-intercepts. So it's going to be like this. That's the first piece. And then the second piece is the blue. I'm going to draw in blue. Y equal to 3x minus 3, so y-intercepts is negative 3. So negative 3. X-intercepts is going to be 1. But again, I'm only draw from negative 1 to 2. When x equal to 2, y equal to 3, so it's going to meet in here. And when x equals to negative 1, it's going to be a negative 6. 6 here, negative 1 is going to be here. So this is my curve. It passes all the points I want. Last piece, green. Let's do the green piece. Y equal x plus minus 5. So y-intercepts will be negative 5. X-intercept will be negative 5. X-intercept will be 5. Yeah, y-intercept negative 5. X-intercept will be 5. So it's going to be, but again, it's only between when x less than negative 1. When x is negative 1, y equal to negative 6. Okay, so it's going to be here. And it's going to be like this. The last case. So this is your final answer. Let's have a look this question. This question also have two absolute values, but one is x, one is y. So this time the both two variable x and y is going to happen on the number plane. I'm still going to change it into pieces, but how many pieces we're going to change? Let's have a look. So on the number plane, we have x and y axis. Let's just make it the x and y axis. Okay. So the first piece I'm going to make it is if both x and y both are positive. So let's say if x and y both positive, it's going to be in this section here. I'll show you. It's in here, both positive. So for the first piece, it will become, when x positive, absolute value will be positive x. And then when y positive, absolute value will be positive y. And then that equal to 1. So that's the first piece. And I'm going to do similar for the second piece. I'm going to using the blue. When x positive, y is negative. So they're going to be in this section here. X positive, y negative. So then my pieces will become x positive, still positive x, y negative was going to be negative y equal to 1. So that's second piece. Okay, let's do the next piece. Next piece, let's do these colors. When x is negative, y is positive. So it's going to be this one. Oops. This one. Show you. Going to be here. And then, so when x negative, absolute value x would be negative x. And y positive, so absolute value y, just positive y equal to 1. All right, okay, there's one more piece to go. The last piece is when both x and y are negative. So it's going to be here. And then my functions become negative x, negative y equal to 1. So I'm going to draw all these 4 pieces on the number plane. First one is the red. X plus y equal to 1. Both x and y intercepts are 1 and 1. So it's going to be this only in the red sections, in the red. And the blue sections, so x-intercepts would be 1, y-intercepts would be -1. So that's the blue sections here. So it's going to be this one. And then the next one, I'm going to do the green sections. Green section is x-intercepts is -1, y-intercepts +1. So that's going to be my green sections. Okay, last one, the yellow sections. So both x and y is negative, so it's in the yellow. And the x-intercepts would be -1, and the y-intercepts would be also -1. So it's going to be like this is my last one. So you can see I actually made a square with the x-intercepts, y-intercepts 1, and the -1.